So welcome everybody to our fourth season, the 2024 Virtual Orchard Meetup Series. We are giving a little bit more time for people to join, and our fourth season, this season, is called Water Wisdom, Navigating Tree Fruit Production through Drought and Deluge. So we feel that is very appropriate. A lot of our Washington growers have faced some of these issues, and we're probably going to be facing some of these issues in the future. And we just heard from the east side that you are facing also some random rains. So just to give some time to others to join, I would like to start by introducing the webinar series. Initially, we started this series in 2021. This was Mario Miranda Sazo idea after an IFTA meeting where we realized that we didn't have so much opportunity to share the experience from the growers, and there were, in many cases, missing time for Q&A with the speakers. So this came up as an idea to get the growers together from the US, North America. We've been joining over the years with and partnering with BC, Canada, and Ontario. So we've been growing in the last 3 years. And in this session, we want to just focus entirely to water trends in water availability today in our first session. And then in the following sessions, which are every Thursday at 4 p.m. Pacific time and 7 p.m. in Eastern time, on the role of water in tree fruit physiology. In June 20, we want to cover the smart watering, so focusing more on irrigation practices and management. And we would like to end on June 27th with all the participants, speakers, and panelists to try to wrap up and get a good information for growers to move forward. I would like also to introduce the team, which, as I mentioned before, has been growing over the years. I would like to start introducing Daniel Weber from Penn State University, Emily Lavely from Michigan State University, Caitlin Hengel from British Columbia Extension, Christy Greig-McGuffin from Omafra, Canada, Lindsay King, British Columbia Extension, also Canada, Mario Miranda Sazo from Cornell Cooperative Extension, and myself, Bernardita Sallato from Washington State University Extension. Before we move on, we want to let you know that we're going to have, this is the format of the session is having 2 expert academic speakers on a specific topic. And then we're going to move, and the idea is that everyone can participate, but we have selected representative growers from each of these regions so they can share their experience and challenges. And so we're going to start with the 2 speakers, then we're going to move to a short poll to identify what are the things that the audience is facing. And then we're going to move to this open discussion with the panel. And we would like you all to participate and ask questions using the chat box. So don't use the Q&A. We would like to keep everything, and we're going to be monitoring the chat box for you to ask additional questions. So Mario, I will now pass it to you if you want to add something and also to introduce the speakers.
Yes. No, so I would like just to emphasize the format of how this was born, this idea. Remember that we start with the conference in Washington in December every year. And we always move from Washington, British Columbia, the Midwest, Michigan, New York meetings, New England meeting, the Mid-Atlantic meeting in Pennsylvania. But we also we had the opportunity to get together. Sometimes the venue that get together many growers in the US is through IFTA, but even IFTA sometimes not enough. That is the reason why we start collaborating and talking during the winter months with this team that have been growing and discussing what we can bring in the summer series before everybody gets too busy with cherry in Washington and with apple harvest later. So this is not the traditional conversation of a webinar or a workshop. This is something more relaxed, and we want you to participate. We want you to type your question in the chat box and be very interactive and have fun. Here in the Northeast, it's late. It's a little earlier there in Washington, but we want to make sure that all of us learn from each other. That is the idea, why we are connecting virtually after COVID. Okay, so that is the main thing. So I feel very lucky, and it's a privilege for me to introduce our next speaker, Dr. Denise Nielsen. Dr. Denise Nielsen is a recently, I think, retired research scientist after having worked for over 3 decades with Agriculture and Agri-Food Canada on a range of topics, including nutrition, irrigation, and climate adaptation for a number of horticultural crops. So her work, particularly in optimizing irrigation strategies and nutrient management, has been pivotal for the fruit growing industry in British Columbia. Even though she is retired, she remained an honorary research associate and continued to be a major contributor to the agricultural community, especially on issues related to climate and water. So we are very pleased to have Dr. Nielsen with us here today to help set up the stage for this 2024 webinar series and speak to a topic that she knows very well. So please welcome Dr. Denise Nielsen.
Thank you. And I'll get going right away and share my screen. So thank you very much for inviting me to talk to you. I gave a similar talk to the IFTA meeting in February, but I have changed it slightly, so it won't be exactly the same. I want to first acknowledge that all of the work that I'm talking about has a whole team behind it, and in particular, Kirsten Hannum, who is my replacement at iCanada. So when we look at climate change in agriculture, there is a four-way interaction. We have impacts of climate events, weather events on agricultural production. We have ways to adapt, and I think people will be talking about this quite a bit today, or during this series rather. But we also have impacts from agriculture on greenhouse gas emissions, particularly from the use of nitrogen fertilizer and also from the implements we use. And we have the opportunity to mitigate by perhaps increasing the amount of carbon in the soil or reducing the amount of nutrients that we add. So our interaction with climate is complicated. There was a discussion yesterday by the UN General Secretary who talked about what is happening with climate over the last 100 years and where we are now. And as he says, we are on the highway to climate hell. So I'm not going to belabor that, but if we look at the average temperature for the 20th century, it is 13.9 degrees Celsius. This is worldwide. We see a trend, an increase of 0.6 degrees Celsius per decade. The IPCC has projected that the severe effects threshold of 1.5 degrees Celsius will be reached by 2029. And in fact, we're already reaching this, and the last year in particular was quite remarkable in that sense. So we see this signal, and I'm going to illustrate this talk with both with global, regional, and some local examples. And I'm just showing some local examples here from Summerland, British Columbia. And this is what we see in the trends in climate. During that time, we see that particularly winter mean daily minimum temperature has increased over the last 100 years. And those trends are evident in that, particularly in winter temperatures. We also see growing degree days as starting to increase, and we see the absolute lowest minimum temperature starting to increase. And what that has meant in our region and in other regions is a changing crop suitability. So here we see, for example, we now have enough minimum winter temperature is high enough that we can grow Merlot and Sweetheart cherries and old grapes in areas that we weren't able to before. And we've had 30 years of those mild winter temperatures that have allowed that. But we did have something happen in the last couple of years that I will talk about a little bit later. The other thing that we have to really remember is that climate is exceedingly variable. And this is basically the interannual variation that we see in weather. And it's this that is much more difficult to deal with than these trends that have been having an effect on us. So if we look at our region, the Okanagan region crop distribution, what we see is we've had a change from being predominantly an apple growing area to becoming more of a cherry growing area and a grape growing area. So these are the consequences of climate change that we see in terms of crop production in the region. So if we're looking at climate change, we have to have some tools, and the most important tools that have been used worldwide are climate models. We have three kinds: global climate models, Earth systems models, and regional climate models. And essentially, these are physical models that link the atmosphere, ocean, and the surface processes in land that affect weather and climate. And this graphic basically, it shows the interaction between all of these things. However, we have to remember that climate models can only project and not predict, because there are huge sources of uncertainty in any predictions that come out, or projections, I should say, that come out of climate models. And these are the sources of uncertainty when we look at climate projections. So first of all, there is the internal variability. This is the interannual variation in this case, temperature. And this is just due to the chaotic nature of weather. Then we have model uncertainty. So we have all these climate models, and those arise because we really do not understand climate as well as we could, and we have limited computer and human resources. And then finally, there is scenario uncertainty. So if ever you see anything that comes out of a climate model, there is always an associated scenario. So we have scenarios that try to predict how society will behave, whether we will continue to use greenhouse gases in the way we do, or produce them in the way we do now, or whether, if we look at this scenario at the bottom end, whether or not we will reduce the amount of greenhouse gases that we produce. So these are all things that can affect temperature. If we look at a regional impact, this is the changing distribution of cherry production historically in our region, and we go from the 1960s up. This graph only goes to 2010, but basically the green areas are the areas that are suitable for sweet cherries, and we have used a whole series of models of dormancy, cold hardness, phenology, and season fruit development in order to create these graphs. So what we found when we started to talk to growers is that, in fact, they'd already anticipated this. And all these arrows show where, in fact, production has continued to increase both upland and up latitude, so to the north and at higher elevation. But the major limiting factor for all of this is minimum winter temperature. If we start to look at future areas that might potentially be available, we can see that in fact this spreads out by the 2050s. This is looking at modeling data, and we can project that in fact there are many areas, including very high elevation areas that apparently might be suitable for growing sweet cherries. So at this point, I feel like somebody on an ad saying, "I will sell you something for $29.99, but wait." And this is the but wait part of it. We've looked at climate trends just very generally, but extreme events are really what is defining what is happening to not just agriculture, but worldwide in terms of climate impacts. So Previously, it's been very difficult to demonstrate that extreme weather and climate change are related, but in fact now, because there have been enough extreme events, it is in fact possible to do so. So the important factors that are really changing and having an impact on extreme weather and climate change are changing ocean temperatures and changing circulation patterns. So weather extremes, for example, minimum winter temperature, often define where a crop can be grown, but they also can provide big seasonal challenges. And I'll just illustrate that with what has happened in our region in the last couple of years. So before I do that, I do want to talk about the jet stream and why it is so important to take it into account when we're thinking about what is happening with extreme events. So the jet stream, narrow band of fast-moving air between cold and warm air masses, it's driven by temperature differences and deflected by the Earth's rotation. As those temperature differences decrease between Arctic and mid-latitude regions because of climate change, that wind speed decreases and causes the jet stream to form these big loops or meanders. So it's basically changing the way in which the jet stream behaves. And this affects both summer and winter weather. And I think we currently have one of these big loops starting to build in eastern North America. So what happens when those big loops start to develop? So when we have a weak jet stream, a strong jet stream rather, it's basically it's circumpolar almost. It basically is more or less straight on one latitude. But as soon as we get these meanders, what happens is that the stormy areas, the blue areas, and the hot areas become stagnant. They become fixed, and this is what causes large problems in terms of intense heat and intense cold events. So we know from looking across the world that these extreme events are threatening both food supply and communities. I've just put a few illustrations here. These are from Chile, where recently there's been a mega drought over many years, mega fires, large-scale flooding. Similarly, California has had many years of drought, followed by these occasional floods caused by back-to-back atmospheric river in this particular case. So we have extreme precipitation happening as well as extreme temperatures. And of course, fire has been a consequence, particularly in the West, but also all across Canada last year. So this is a serious issue for all of us. Back in 2006, the BC Ministry of Agriculture basically started to worry about what, in fact, climate warming impacts might be on food security, and suggested that, in fact, we needed to look at new production areas to provide a healthy diet, and that these should be irrigated for efficient production. So they suggested that a 30% increase in production was required. So when we start looking at this, these expanded production areas, what are the risks that are associated with that? Well, if we start to expand into regions that are previously unirrigated, then we have the possibility of our water supply becoming more unreliable. And the second thing is, of course, we start to plant in areas where previously, 30 years, we've had no issues. But this year, in 2024, we had a severe cold event following a very mild winter. So there were some issues with development of hardiness, but essentially we had a large destruction or damage of primordia and buds in sweet cherry. And I think we can probably say this is an example from the research station, and I would not take too much away from it in terms of rootstock. It's a very small sample, but it does give an indication that we probably are looking at 40 to 50% of normal crop in many areas, and perhaps even more damage than that in some regions. And so we know that crop losses are due to climate change and extreme weather have become very costly. And we can see this if we look at what has been paid out in US crop insurance in the last, since 1995, we can see that there are peaks years where, in fact, we get more and more effects of extreme weather, in particular drought and high temperatures, and which is the red bar, and excess moisture, which is the grey bar. So I'm just going to quickly change now to talk about water resources, because I know that this is what we're really interested in this this seminar. And we can be certain that global warming will change demand, it will increase demand, it will make supply more uncertain, and potentially the costs are going to be much higher. So if we look in the world context, if we have an issue with irrigated agriculture, which we have to remember is the more efficient method of producing food, we're going to have increased food insecurity, particularly worldwide. And in a regional context, we start to see, as I demonstrated with that idea from the BC Ministry of Agriculture in 2006, the idea of increasing food self-reliance. If we look at changing water demand, if we start to expand irrigated areas to meet food requirement, then we're going to need more water. We're also having to grapple with increased evapotranspiration because of those higher temperatures. And we have to remember that there is going to be increased demand from other users. And this is something that sometimes we don't take into account very much, but this demand from other users. And finally, perhaps the most important component is changing water supply. In Western North America in particular, we are dependent on water supply from snowpack. We know that we have this swing from drought to flood, and how are we going to deal with that? We have an issue of timing with future supply. Right now, all our systems are geared toward historic spring melt, and that spring melt might change. And then we have an increasing pressure to take into account ecosystem requirements that, quite frankly, when we first started developing irrigation systems in North America, in Western North America, we really didn't pay too much attention to those. So these are all of the factors which are going to have an impact on both supply and demand. And this is very obvious if we look at some of the information coming again, and I'm focusing on the West because this is where a large proportion of irrigated food is grown. And it depends on mountain snowpack and glacier melt. And if we look at this graph, this is from 2006, this figure, but all of the red areas are an indication of where snowpack has declined over a 30-year period. This was done in 2006. Sorry, so it's 1960 to 2002, so it's a bit more, and it's a 42-year period. We see glaciers basically retreating at an alarming rate. I visited the Columbia ice fields last year, and I was astonished at how much it had changed since I last visited in 1990. So it's the Athabasca Glacier, which is part of the Columbia ice fields, which is part of which contributes to the Columbia River flow, is retreating at 5 meters per year. So it has reduced 50% in mass since the early 1900s. So high variability, decline, a lack of reliability, and of course we look at Lake Mead, lack of water coming into storage. And this is reflected not just in these areas that I've shown, but throughout the West. And we can just see the same thing. Regional impacts here is measured and modeled snowpack, but basically this is the model here. And these are the measurements, and we can see that in April and May, this is a mid-elevation snow course, snow pillow. We can basically see that since 1965, there has been a decline in the reliability of that snowpack. Looking at models, this is some work that was done again quite a long while ago, but this again is for our region, and basically showing a decline throughout this century in the availability of snow for snowmelt, for stream flow, and for potentially for irrigation. The other thing that is happening is the change in the timing of freshet. So it used to be that if we looked at 1961 to 1990, 1991 to 2018, that's the black and the blue lines, we see that we're basically, the freshet is occurring probably, I think that's early June in this flow, and it's starting to get earlier in 1991 to 2018. And then if we look at 2011 to 2018, we see that, in fact, it's not only getting earlier, but we're having what are called rain on snow events. So essentially, it's snowing, it's raining with some melt. It's snowing, it's raining, it's melt. So this makes storage and use of the stream in the future much more difficult. So the current shows that freshet is 15 days earlier, more evidence, as I said, of rain on snow events, and such changes when we did the work that we did back in the early 2000s were previously forecast or projected for the 2080s. So this is what is happening with much of this climate modeling that was done 10 or 15 years ago. What we're seeing is everything is happening much more quickly than we expected. So we see this is the sort of shape we're now seeing for the hydrograph. So what tools do we have to look at this? I know we're going to have a talk right after this one about modelling and modelling tools, but I just wanted to talk a little bit about the water supply and demand project that was done within our area. This is a water demand model that I developed with Ted van der Goort from BC Ministry of Agriculture. And it's a very detailed model that calculates daily water use for each land use parcel and is linked to water source. And it can look at demand for all uses for all types of areas, subbasins, aquifers, areas, water purveyors, local government. And it also has built on top of it, aside from the agricultural component, the use of water for domestic purposes and institutional and industrial purposes. So we did a study back in 2006, and basically what we saw is that we have this apparent large irrigation license that is only being half used. If we start to look at climate change and land use expansion and population change, we start to see that, in fact, we are getting closer to that potential license. But in fact, it's unlikely that that license could ever be met. So we have issues that are coming along. And if we start to do a little bit more modeling, what we start to see is that when we look at warmer, drier scenarios, we get more rapid snowmelt, as mentioned, and earlier freshet. These reservoirs, Mission Creek is the major contributor to Okanagan Lake. In our modelling, between 2040, it's not as far along away now as it was when we did this modelling, both irrigation districts had insufficient supply 50% of the time. So these are, these are basically modelling outputs. But I think what we're seeing in reality is starting to bear out some of the projections that have been made under this modelling scenario. So I alluded to this earlier, but we have to start taking into account other water needs. First of all, again, our region is a poster child for all of the potential conflicts that could happen over water. We have a very rapidly, particularly in the central Okanagan, increasing population. And we also have a much greater awareness now. This is from our local First Nation who have put forward their own ideas for how to manage water. And so we have to start improving our understanding of both the regulation of environmental flow requirements, which is low flows basically in the summer, and other ecosystem needs. So these two things are starting to play into this issue of climate change and its impact on water availability. And this is just a slide that I present to a group of students at UBCO when we're talking about water resources and how we have changed in the way in which we look at water resources. When we first started building all our dams and systems, it was a resource to be exploited and managed for human activity. Then we moved to a stewardship model, and I think that's where we are now. But in other regions, in New Zealand, for example, rivers have been given the status, a legal status of as an entity to be respected and protected, just like a corporation might be. So they have basically been granted the rights of personhood. So, you know, we may have to start moving away from some of these types of systems also, because we're finding that they're failing, that they may not eventually provide us with the type of water management that we need, particularly where we're starting to see floods and droughts. We may need to start thinking much more of allowing ecosystems to be basically functioning as they can be to provide buffers for drought and flood. And I just mentioned this book here. It's something I recently read. It's a reporter who has basically taken lots of examples of ways in which water management where we failed and where we've won. So I think it's an interesting read for anybody who might want to be. So just in summary, the effects of climate change on temperature and precip are occurring much more quickly than previously projected. We know that crop distribution is based on weather conditions that have prevailed over the past century, but things are changing and crop distribution is also changing, and that brings risks. Rising temperatures can also have a negative effect on the viability of crop production in some regions. And in the future, basically, climate effects can only be projected by models which have considerable uncertainty. And we know that it's much more difficult to predict extreme events, which maybe in fact be the limiting factor for crop distribution than climate change with modeling. So this is something that we would have to build into our thinking. And so those challenges from high and low temperatures and unreliable water resources are likely to persist. And I think it's behooves us all to try and think of ways in which we can manage this, not least of which, aside from the economic considerations, but also from the lens or through the lens of continuing to produce healthy food for people to consume. And with that, I'd like to say thank you, and I'm finished.
So thank you so much, Denise. If we don't have questions now, we're going to move forward to the next speaker, and we're going to leave kind of some questions at the end. So now we're going to present Dr. Kirti Rajagopalan. She's an assistant professor of biological system engineering in Washington State University. She has a very impressive curriculum. She has a PhD in civil engineering, an MBA, and a bachelor in civil engineering. So Kirti works on agroecosystem modeling to help inform regional scale natural resources management. So she transitioned into academic from a career in the finance industry after pursuing a PhD in civil engineering. She's currently enjoying life as an assistant professor in the biological system engineer department at Washington State University. I understand that she also teaches hydroclimatology, agroecosystem data and modeling, and water resources engineering. So please welcome Dr. Kirti Rajagopalan. Thank you.
So good evening, everyone. I'm happy to meet new people and learn something as we have the discussion after this too. And thank you, Denise, for setting up some of the background for some of the things that follow in my slides here. Most of this is focused on the Pacific Northwest because that's the area that I primarily work on. But I think a lot of these insights are applicable for the rest of the country and other locations as well. So this presentation has some information about climate change implications for irrigation demands and water availability. And I want to start out acknowledging Matt Urek here. And let me see if I can get my laser pointer too, who was a PhD student and a postdoc now in our lab, who's done a bunch of the work that's presented here. And there's several collaborators we've worked with on all of this too. So this whole session is about water availability. And really, water availability has two pieces to it. There's the demand side of it and the supply side of it too. Both are expected to change, and how they change relative to each other is quite important in determining what the water availability would be. And I think there's 4 key aspects, and that's what I'll try to touch on here. One is the irrigation demand magnitude and timing itself, and not only for tree fruit and our field and our crop of interest, but for everybody else and the whole region, because that's what determines water availability, and that's what's using the water that's common to the entire region. Then the other piece of it is how irrigation demands and other demands and water supply kind of come together and result in irrigation water shortages, especially under this umbrella of water rights, which is prevalent in the Western US. And then there's aspects that we haven't really looked at before, but are starting to look at now, which is water for extreme heat management or other kinds of extreme weather management. And then, as Denise mentioned, and I tried to allude to earlier, like all of this affects and is affected by the entire system, where we have these water resources, not just for irrigation and agriculture, but flood control and recreation and fish and other endangered species needs, and navigation and other aspects of both in-stream and out-of-stream uses. So just as kind of a summary before starting with irrigation demands, one thing that we know with warmer temperatures that will increase is the atmospheric evaporative demand, or how much, what potentially is evaporatable from the environment. But then when you translate that to actual irrigation demands, it can increase or decrease depending on the context. And we can get to some examples of that later. But then other than that, there's also shifts in the timing of crop irrigation needs. And that's important for a lot of Western US because water rights are given for a specific quantity, but also a specific season of use. And so if the time in which the demands occurs are outside of that season of use, then having that water right modified to account for that becomes important. So there's the timing and magnitude part of it. And then with water shortages, generally in our area, we see increased water rights curtailment or pro-rationing, and we'll get to what these mean. But essentially, this is looking at access to irrigation water for farmers whose water rights are junior to in-stream flow requirements. So when the flow in the river goes below a certain requirement, their agricultural water right is cut off to leave water in the stream. And so their ability to produce tree fruit or whatever their product is compromised. And then the idea that we need increased water for managing extreme heat exposure. So these are the 3 things that I'll try to touch on. And, as with other things, a lot of these things are not observable because we are looking at future climate and we are looking at large regions. And so we answer these questions on how demands and supply change through modeling efforts. And one of the models we use is what's shown here. It's called VicCropSys. It's a coupled crop and hydrology model from which we are able to simulate water supply and water demand dynamics and then put them together along with information about water rights and such to get at water availability. And so before we get to what the results are, some of the main drivers that these models are trying to look at, especially with changes in irrigation demands, are first temperature effects. We know the temperatures warming in general, though there's fluctuation around it from year to year. And this warming, as I noted earlier, increases the atmospheric evaporative demand. We also have a longer available growing season that is frost-free. But even though the growing season availability is longer, there can be a shorter time to maturity because plants have accelerated growth because of warm temperatures. And that shortened growing season actually results in lower irrigation demands. And you see that sometime in a warm, even in historical data, in a warm year versus a very cold year, when maturity and harvest is much earlier, you see lower irrigation demand. So that's a signal that's possible going into the future too. This is not so relevant for something like tree fruit that's managed a little bit differently. And also because there's things like color development, maturity and harvest are not necessarily the same thing. And before you harvest, you need a certain color development, for example. And so you need to wait for later in the season anyway. So the time in which you irrigate can still be longer. Then there's also the yield or biomass impacts. There's elevated carbon dioxide levels in the future that led to increased temperatures, and that makes most plants happy, and you have higher biomass and higher yields. And when you have higher biomass and yields, the plants can transpire more and lead to increasing irrigation demands. But with climate change, the yields can be higher or lower, and therefore your irrigation demands can be higher or lower too. And then there's heat stress impacts too. Other than that, with respect to elevated CO2 levels, other than their effect on yields, it also leads to water use efficiency. So for the same amount of water is able to contribute to photosynthesis a lot better than at lower CO2 levels. So you can have a little lowering of irrigation demands because of that. And then there's, of course, changes in precipitation patterns. So basically, all of these are competing effects, and the effect depends on the crop and the area you're in, what kind of temperature and precipitation regime you begin with. So the end result on what can happen to irrigation demands is quite complex and can be higher by a lot or lower by a lot or remain about the same. And so some of those results from our simulations with respect to irrigation demands, and we have both perennial tree fruit crops and other crops here, just because, as I said, what changes happen to other crops also impact water availability. And this is in 3 categories of crops here. There's the pasture hay kind of crops, there's perennials, and then there's a whole bunch of annual crops. And what's shown here is first the season length, because that impacts irrigation demands too. And so there's the growing season start, the season end, and the length of the growing season. And for many annual crops, if you focus on the reds, the length of the growing season is decreasing. And then, but for perennial crops, they tend to be about the same. And this is looking at the near future. They don't change that much because of the way they are managed. And for things like hay crops that can have multiple cuttings, they can enjoy the full longer growing season. And so that length tends to be higher for that, which can impact irrigation demands. The other aspect is the change in yields itself, because higher yields tends to mean that there'll be higher irrigation demands. And again, there's a bunch of competing effects here, but you can focus on just the red, which is the overall effect of all of this. So in general, for annual crops, you can see a little bit decrease in yields or staying around the same or a little bit higher. It depends on what crop you're looking at. But generally for tree fruit crops, we don't simulate much changes in yields, again, because of the way they are managed. But for hay crops, for example, you can get an extra cutting and you tend to see increases in yields, where the y-axis is the change in yields here. And then combined with all of that, how that translates into changes in irrigation demands is you tend to see small increases in irrigation demands for perennial crops, decreases for annual crops, because the actual growth season is shortened quite a bit, and then increases in hay crops. That's what we see, and this is all based on the Columbia River Basin area as an aggregate of that. The one thing that's key from all of this, though, is one thing we know for sure across crops is the early season irrigation demands are expected to increase because it's warmer earlier and the plants can grow earlier. And then the late season demands, you can see decreases because some plants, especially annual crops, are maturing earlier. And so if you take that all and look at an annual effect, it's all over the place. Some places say increases, some places see decreases as a function of the crop mix, which can also change in a changing climate, as Denise mentioned too. So I'm highlighting two areas here that the locals in this area will be familiar with. One is the Yakima River Basin, where there's a lot of tree fruit. You tend to see blues, that is increases in irrigation demands, versus the basin project area where there are a lot of annuals where you tend to see decreases because of the crop mix. This again is just this is the magnitude, but also the timing where you need more water early in the season where your water right may not be written to account for that. So that's something to account for. Then how this demand, along with changes in supply that Denise alluded to, a lot of these places are snow melt driven areas. So you see earlier melt, and if your reservoirs are able to capture that and give water later in the season, that's great. But if that's not a possibility, then the changes in the timing of supply can result in shortages. And so these shortages in this graph, what's shown is for the Yakima River Basin area, where the way shortage happens is some irrigation districts are junior to others, and those that are junior get a certain fraction of their water right. So it's not cut off completely, but you get a certain fraction of the water right. And what's shown here is the historical frequency, the percent of years. So in Yakima, about 1 in 5 years, there's a shortage. And historically, that's the 20% here. Versus in the future climate simulations, and this is the near future, you expect that frequency to almost double in the multiple scenarios. So this is one scenario with lower emissions, and this is a scenario with higher emissions, but you expect the frequency of shortages to almost double. And this here is the proration rate, or the fraction of their water right that they get. So historically, when there is there is a drought year, and when they get less than 70% of their water right, which is what leads to some kind of serious impact on production, on average, the amount of water received is about 55% or so when those conditions are met, which is not in all of the years, but few years. But going into the future, the percent of water that they can expect to receive is lower, closer to like 40% when those events happen. And this is the near future. And when you look further out into the future, those percentages tend to decrease a little bit more. So definitely increased frequency of water shortages and the level of water shortages. That's also true for other places, unlike Yakima. This is for Wenatchee, for example, where in certain weeks, if the stream flow is less than a certain threshold, irrigators junior to the stream flow are shut off. And so this is showing the change or difference in the number of years with curtailment. And you see that in the future, there's a lot more years with curtailment as compared to historical timeframes in much of the season. So that is something to deal with too. In terms of water for extreme heat management, this is something that the models don't account for at all now, and something we're just starting to account for. And the reason we got to looking at this is something that's unrelated to water. We were working on a project that was looking at climate change impacts on sunburn in apples. And so on the x-axis here is the number of on the y-axis here is the number of sunburn days. And then here's the timeline from historical all the way into the future. And there's the two scenarios, the lower emissions and lower temperature increase scenario and higher emissions and higher temperature increase scenarios. And two varieties, one that the Crips pink that has lower susceptibility to sunburn, and Honeycrisp that has a higher susceptibility to sunburn. And so we were looking at the number of sunburn days for three conditions. One, when there's no shade cloth netting. And there's a lot of shade cloth netting adoption these days, and there's different kinds of shade cloth, some that restrict the radiation or sunlight a little bit less, and others that restrict it a little bit more. So those are the two kinds of netting in here. And the yellow line here corresponds to a no knitting baseline scenario. And then the other two are the two netting scenarios. So, and this is Washington State. And in Washington State, if you look at the current conditions, for Honeycrisp, which is a susceptible variety, there is some sunburn risk, but netting and whatever kind you use is able to handle that risk. And as a strategy, that's good enough. And other strategies like evaporative cooling may not be necessary if you have netting included in your field. But moving out into the future, it's no longer as good a strategy. So there's a sunburn risk even outside of what netting alone is able to handle, right? Even in the mid-century or especially later in the century too. And this new y-axis here corresponds to the amount of additional water that's needed through evaporative cooling to make up for what netting is not able to handle. And the important thing here is that the additional water that's needed here is a lot more than the changes in the crop irrigation demands that we were looking at earlier that all our models are considering. So this is a big piece of increased demands in the future potentially that we are not accounting for, and something that we cannot ignore. And something we're starting to focus. And it's also important because there are people who netting obviously reduces the crop's water needs. And people are trying to use that saved water in their water right to seek permission from the Department of Ecology, which is a group that manages rights here, to use that saved water for other purposes, which works fine in today's environment, but maybe that's water they need for irrigation purposes moving forward later into the future. So that's something to keep a watch for. So that was basically it. Going back to the summary, the irrigation demands can increase or decrease depending on what the situation is, but there'll be changes in the timing that can have consequences. We can expect increased water shortages, and then we really need to start considering water for extreme heat management. Thank you.
Thank you so much, Kirti, for that talk and that amount of information. Thank you both, Denise and Kirti, for the information that you provided. Before we move on to the conversation and the talks, we have a short poll that we would like to run through the attendees. So Lindsay King, she's in the tech side, and she's going to run a poll for the attendees to start answering. This very short 3 questions, but we want to get a feel of what the audience is experiencing.
Hey, here we go. I hope you all can see it now. Did it pop up for you, Bernardita?
It does, yeah, I have it here.
Okay, so we have 3 questions here. The first is, have you noticed any changes in climate patterns affecting your orchard over the past decade? Yes, no, or unsure. And then the next question is, if yes, please specify what type of environmental challenges you have experienced. And there are a few different options here. Increased temperatures, changes in precipitation patterns, changes in water availability, changes in water quality, extreme weather events, pests and diseases, or other. And if you select other, please tell us in the chat. And then the third, how have these environmental changes affected your crops and operations? And again, there are a few options there. And if you select the other, please tell us that in the chat as well.
Very well. Thank you, Lindsay. So I'm going to start with the unsurprisingly, the first question. If you have noticed any changes in climate pattern affecting your orchard, we see that still people answering, but about 85% indicate that yes, and 11% uncertain of those changes, and only 4% have indicated no changes in the climate patterns. Lucky few. If yes, please specify what type of challenges you have experienced. So we have here that most of you, 71%, have seen changes in irrigation patterns, so more or less rainfall. We also see it's increasing the number now, increasing temperatures. And we also have here extreme weather events like storm, winds, hurricanes, and also the increase in pests and diseases. And for the last question, how these environmental changes have affected your crop and operation, we see that 70% indicate increased pest and disease pressure. And also 57% changes in fruit quality, and 43% indicate decrease in fruit yields. So now I have at least a lot of questions, but we would like to start introducing our panelists, our growers from the different regions. I'm gonna ask them in order of from the west to the east. So we will start. Please, if you can introduce yourself and briefly also describe your operation. So when you share later experience, people or attendees can have a sense of where you are located and where your main challenges might be. So we're gonna start with Aaron Erlacher from Washington. Aaron, could you introduce yourself and your farm?
My name's Aaron Erlacher. I work for Zirkle Fruit Company. I'm an area manager in Mattawa, Washington, so located in central Washington state in the Columbia Basin. Pretty hot climate here. Summers, it's not, abnormal for us to hit 105 several days out of the year, 4 distinct seasons. It is a desert, so it is hot and dry, and 8 to 10 inches of precipitation a year. So yeah, we farm about 2,000 acres in this area, and most of it's apples, cherries, a couple hundred acres of cherries and some blueberries. About 80% of that is organic. But yeah, it's just a hot growing district. Has been since I was a kid. And it's a little more challenging than some of the cooler areas, but I don't know. Did I answer the questions I needed to? Or
Yes, you did. Thank you
Okay.
so much for that. And we're going to go back to you later when we go in deeper into the challenges. But now
Gotcha.
I'm going to move to Molly Thurston. She's from BC. Molly.
Hi, everyone. My name is Molly Thurston. There's two parts to my operation. One is a 7.5 acre mixed organic farm, which is located in the central Okanagan, so up Highway 97 in British Columbia. The climate is very similar to what Erin just described. It's a very dry region, and we've certainly been having lots of hot summers. And unfortunately, as Denise described, we did have the polar vortex event that caused quite a lot of freeze damage in our stone fruits and quite a bit of death in our vineyard areas. I also have a second portion to our operation, which is located in the Creston Valley, so right up across the Idaho border from Bonners Ferry. And that area is primarily a cherry growing region, and we farm 30 acres of cherries in that region that are commercial and are planting apples and pears. And we have a cattle operation that runs out of there as well. I think that's about what you needed to know.
Yeah, thank you, Molly. We're going to move up north to the east side to Ontario. Is Brian right out around here? Yes, I see him.
Hi. So we're located in southwestern Ontario. The farm name is Mandatory Fruit Farms. It's a sixth generation now fruit and vegetable farm. We're equally divided right now between apples and tender fruit, with about 100 to 125 acres of each. The farm is located in the microclimate of southwestern Ontario, which is right on Lake Erie. So we're able to benefit from the the gentler or colder springs, kind of help us grow frost-free because it stays cold. It doesn't really warm up very quickly. This year it did. And then we benefit from that into the fall because we have that milder fall due again to Lake Erie. And we're basically on, like I say, in a microclimate, and we grow on what's called fox gravel, which is a self-draining soil, to Brookston clay, which doesn't drain. So we vary our crops depending on our soil type. So we use those, even on our own little farm, we use those little ridges to grow specialty crops or specialty tree fruits. So yeah, that's basically us.
Thank you, Brian. And I also have here from New York, David and Kevin Bittner.
Hello. So we're from Western New York, along the shores of Lake Ontario, and just like Brian, we're in a microclimate of the lake. We have about half mile of lake frontage that we grow apricots and sweet cherries on, about two acres of stone fruit and 2 acres of apples. And same with Brian, we have some really good 330-foot deep sandy ground to clay that I don't know why we're on. That's about what we have for our farm.
If you go directly north from Buffalo, our farm's right on the shore of Lake Ontario.
Thank you, Kevin and David. I'm not so sure if we have anyone from Michigan that can share some of your conditions.
Not today, Bernardita. They couldn't make it.
Okay, thank you, Emily. So thank you all for being here, the panelists. And now we encourage everybody to ask questions in the chat. But one question that we would like to follow to the panelists is, some of you touch a little bit on the conditions that you have faced, but what are those conditions that that have been more challenging in the last maybe 10 years? And if those conditions have changed your decisions in terms of what you're going to be planting, on how you're going to be planting. So maybe I can start the other way around with David and Kevin. Would you like to share those?
We're changing little by little. Anything new we plant now has irrigation, where years ago we were able to get by without it. We're also installing drainage in more of our farms than we used to, a grid tile and 40-foot center. And we're careful about our locations. We are transitioning more apples, less stone fruit, because some of our varieties of stone fruit are more sensitive to, we've been getting more extreme freezes and frosts than we used to. Historically, the last 2 springs, we've gotten some pretty good freezes. Do you want to talk about irrigation?
With the weather change we've had, we've probably been about summer rainfall throughout the year as we usually do, but it's been more intense and less frequent. So last year we had a rain event that was 7 inches in half an hour. That a couple of our neighbors had some nice washouts across the road with sand into our orchards and everything else. Then you followed by 2 months of nothing besides some misting. So that's mostly why we're doing triple irrigation. Because usually we get 18, 24 inches of rain during a season a year, but it's so sporadic now that, definitely new planting apples, new planting stone fruit. That first season, irrigation pays for itself. We can justify the whole cost. What's unique for us is irrigation is all municipal. We don't have a single pump, single sand filter on our system, but we also probably one of the cheapest municipal water you can find in the country. So that's our advantage with that.
So just to follow up on those challenges, so you having more sporadic, like extreme events of rain. What about the heat?
Usually being right at Lake Ontario, we don't hit above 90 degrees, but we've had that happen a couple times last couple years.
So what about you, Brian?
Well, the fun term for us is we're in the banana belt of Ontario. So we're actually the same parallel as Northern California. So we are actually quite a bit further south than some places in Canada and in the United States. So weather patterns are just like Kevin and David said, like they're all over the place now. We don't see a storm that doesn't seem to bring something with it. We've always had challenges being on Lake Erie. Our storms come out of the Southwest a lot, so we get a lot of donations in our fields and in our orchards from the Ohio Valley. It comes across in the winds. So we used to do a lot of overhead irrigation, and so we were mostly a vegetable farm then. We've switched to drip irrigation on 200 acres of our orchards, and I'm glad we have. We tried drip irrigation in our strawberries, but we have gravel. That kind of didn't work very well, but it helped mitigate those dry snaps and allowed us to carry through to the wet spell again. Because like they said, you get this, like this year, like we're in 7 inches of rain in the last 10 days, and we may not see rain now again till July, right? That's just the way the weather patterns are. So we're able to drip irrigate through those weather patterns and maintain the water column in the soil. And that's our key thing that we want to do, is maintain that water column. So, yeah.
Thank you, Brian. Molly, what about in your area?
In our area, I would say the overarching themes are mostly heat and drought for the last several years. That has made a lot of required changes, I would say, for many of us. Our area would not grow tree fruits without irrigation. It is a requirement because of the area. And the soils I'm growing on range from very sandy to clay loam. And so we had predominantly used micro sprinklers or drip, and we've been moving more and more towards drip or double drip irrigation systems. What we've seen in the last 3 years of sustained drought is that we've lost a lot of our ability to grow the alley crops or cover crops in the orchards with just the drip irrigation. So have started to drift back towards incorporating both systems of drip and micro sprinklers in order to be able to have a cover crop, which we did feel was beneficial both for soil health and microbial life, but also for cooling through those periods of extreme heat. And the orchards that had a decent alley crop or cover crop seem to have done better for us. During the heat dome. So that's something, that was sort of unexpected in that, we've been trying to move towards lower water usage, but then have found that there's certain times of the year that we need to have more irrigation in order to sustain things. So our water is also entirely municipal. In most of our areas, it's also treated municipal, which has raised a number of challenges in terms of shared water system. Denise and Kirti both alluded to that. And so availability and affordability of water are key issues for our grower group as well. Erratic storms have been really something we've been dealing with, whether it be increased wind conditions that really hamper our ability to spray in a timely fashion, or hailstorms that come out of the blue in the summer and increase our risk of fire blight and trauma blight through the season. So those sorts of changes in weather patterns have really affected things. And then certainly the changes in growing degree days have influenced a lot of our management decisions as they come to pest management, disease management. I say over and over, it seems we're not calendar spraying. We need to be checking and monitoring and utilizing our models more effectively. So those are some of the things that we've certainly been seeing, and our management is adjusting accordingly.
Thank you so much. That's quite a lot. Alan, what can you share about your region of production, which is quite important for Washington apple production, right?
Yeah, I think that, like I think Molly was alluding to it, that heat dome event that we had a few years ago, we hit 118 degrees here, and that was just, you hope that's a one-off, because if that continues, it's going to be really difficult. We were doing things like picking cherries at night, and what was really interesting is that we actually had one of our better apple quality years in a long time during that time. So we thought that was interesting. I certainly don't wish that to happen again. We did fry some blueberries, the tops of some blueberry bushes, and we have those, they're covered with shade cloth, and we have overhead cooling. And we do a lot of overhead cooling. I guess, that event, I don't know that it changed a whole lot what we did, because life in the basin has always been battling the heat. And so, just the things that we do to counteract that is, we spray a lot of sunburn protectants. We have overhead cooling, a lot of shade cloth, and, Molly was saying too, like drip is great and I love it, but it also doesn't grow that, that cover crop if you're trying to make more resilient soils and plant things in the alley row. And so there's this battle between, hey, saving water, and then, well, if I want to save water, then I guess I can't, increase my organic matter the way I'm trying to, so there's just things, but yeah, heat's it's a real issue and has been for us. And we've battled it fairly well, but I'll say a few years ago, it got us pretty good. We did lose some cherries and some blueberries. Most of the apples made it through fine. Didn't have any major sunburn issues with that. But it just made us think a little bit more as we develop blocks to make sure we've got that kind of infrastructure in there. Things like shade cloth. All our cherries now, are covered. And so anyways, long answer to a short question. Maybe it wasn't rambling, but that's kind of
very general, very broad question. So thank you so much, Aaron, and everybody to share that. One question that I think Kirti also is mentioning in the chat, just to follow up, have you had to face any changes in the regulations and availability of that water?
Very blessed to have really good water rights here we're on the South Columbia Irrigation District. I've been I've been on this district for 20 years, and there's never really been major issues with us not getting our allotment. I can't remember, I think it was like 5-10 years ago, there was a crack in one of the dams, Wanapum Dam, right next to us up at the top. And they were worried about filling that reservoir behind that. So they lowered it. And some of our ranches that I don't manage, but further north of us, were impacted by that. And they lost their ability to, they were drawing directly from the river. And when the river level gets so low that your pipe is left bare, that your suction pipe out of the river, they just couldn't get water for a while. So I will say our water rights are pretty solid for now. Obviously, that's always in flux because it's only as good as the paper it's written on, and that can change at any time. But things, thankfully, we've had pretty good luck. And the Columbia River, coming from Canada and so many different watersheds and tributaries dumping into it has been consistent for us. But I certainly know that's not the way for everybody. And I know that, the Columbia River's getting affected as well as everywhere else. So thankfully, no, we've had it pretty good here.
And Molly, I believe that that's one of the things that you mentioned on the struggles of the BC growers. Can you share a little bit of those changes in terms of the regulations and availability?
Yeah, and perhaps Denise can share a bit too, as she also sits on the Basin Water Board. So with the region, water is managed on a very regional basis, and there are a number of competing interests. And in my particular area, we've had two very recent issues that have come up for our farmers, although I would say that tree fruit growers were much less affected than forage growers were in certain areas. We did have an irrigation shutoff in May for 2 days that was unannounced, and at a time when there were critical needs of water, and that was because the water was deemed to be undrinkable, and some maintenance needed to happen. And our agricultural water system is tied to a municipal system, and so that did cause quite a lot of discontent in our area. And as such, we've organized ourselves as a Farmers Institute to be able to speak with the municipality on behalf of the farmers in our area on water issues. The other issue is stream flows for fish in the fall for spawning, and our district is required to let down certain amount of water into the streams, which again is coming out of that same pot that's available for agriculture. And so there are concerns that when we're being asked to reduce water or potentially reduce allocations to agriculture, and then water is going into streams for fish, again, there's a lot of misunderstanding and competing interests there. And so we've spent the better part, I think, of the last 6 months on education, educating ourselves as farmers what our responsibilities and rights are, and educating, municipality as well as the other stakeholders. So I would say there's a lot of unresolved concerns out there. Water is short, and already we're seeing restrictions in most of the municipalities that would apply voluntarily right now to agriculture, but are restricting homeowner usage, which is contentious. And then, we expect to probably see further restrictions if we do have this predicted hot, dry summer that's coming. So I don't know, Denise, if you want to come in with a few comments.
Yeah, I just want to mention, I don't sit on the Basin Water Board. The Water Board is actually a collection of politicians. I'm part of and I'm not a politician. I sit on the Stewardship Council, which is the technical advisory committee for the Water Board. And you're absolutely right, Molly, there are many challenges, and I did allude to that, the competing interests. And one of the bright spots, you might not think this, but I did talk about infrastructure, and much of our infrastructure is aging. Our dams, our Okanagan Lake regulation system, our grey infrastructure is aging. And there is a chance now, a time now to actually renew it and perhaps apply some different principles that hopefully will allow our system to work better. And essentially, we have to come up with some really new ideas that have not been thought of before. And so we have to manage our groundwater better. We have to start managing our our wetlands better, and all of these things can help mitigate stream flow, because the problem is the peaks and the low flows. And we have to be mindful of floods because we're a highly populated region. And so there's many things that are going on, but I'm hopeful that, and this sounds political, but it's not, but I'm hopeful that there is now a desire, and it's a lot of it, this is about desire and people being able to work together to actually come up with solutions that benefit everybody. I'm beginning to sound like a social scientist. It's terrible. When I first started in this work, we had a whole pile of social scientists working with us when we were modeling. I thought, oh, what are they doing? And it turned out that they actually were more important than the actual modelers. So it's, yeah, you know, it's all about building that trust and working together. Otherwise, it will become conflict ridden. And that's the same everywhere. There's nothing worse than water conflicts. And you see that around the world. So,
yeah, absolutely. And I see that the Eastern growers did reply in the chat in terms of maybe not so much challenges in terms of the regulations, right? David or Brian, would you like to share any of those if you have experienced any changes in those regulations?
Sorry, go ahead, David. Sorry, David, go ahead.
We're sort of in a unique position with the Narra County Water District. Narra County built a water system in the 60s for an increasing population that never happened. So Narra County region has an overabundance of water capacity, but there is some aging infrastructure that they've done some USDA rural development money to keep it up. So I can hook up to any water meter up any road through our municipality region with a meter, and I get 65 PSI clean potable water. All I have to do is put a filter on for calcium, since our water is high in calcium.
Lucky you.
Yes. And also, like I said, our water is cheap. I pay $1.75 1,000 gallons. But there's neighbors near us that just go over County Line Road from us. They're at $6 for 1,000 gallons. So it changes very quickly in New York State. Availability, regulations. We used to be in another township that was really hard to work with them, even though they had fire hydrants up every road too, that they just didn't want to work with farmers because they thought we were going to attack the system. And some towns are really, because they don't have the capacity and they don't want to invest into ag water capacity.
Thank you. Ryan.
So we're on year 30 of our, so yeah, sorry, we're on the second 10-year term of our 20-year water taking permits. So we're now, like I say, in the 30th year of that process here in Ontario. We're fortunate. We are on a ridge that actually has an underwater river in it. So back in the day, they dug a lot of gravel pits. Those gravel pits, when you pulled out the gravel was actually replaced by water. So we're able to use ponds from groundwater that is coming through sand points. So it's well filtered. If it hasn't been sitting for too long, we don't have to even filter it for our irrigation. We just run it. We're pretty lucky that way. If I want to, my permit does allow me to pull from Lake Erie. We have probably close to 2 miles of 14-inch pipe buried and another 6 miles of 6-inch pipe buried, and then we come off all that. We're not allowed to actually start our pumps up during the heat of the year because we'll actually cause a brownout in town. We have 100 horsepower irrigation pumps. Ontario Hydro does not like us starting them up very often if we can avoid it. So we do have to watch ourselves. That's where our regulation actually catches us, is on our actual hydro demand, not on the water demand. So when we start up a 100 horsepower pump or 2 of them, they don't like that. So the draw on the power grid is actually too much. So yeah, and our system now is getting old. Actually, it's 30 years old underground. So yeah, we're very fortunate.
Yeah, maybe just to share some experience here in the Yakima Valley in Eastern Washington. We had the water cut during this period from bloom time in the middle of cell division for 10 days. So for some of us that have silt loam soils or heavy soil, we were able to keep the trees okay. But I'm pretty sure that there were some areas that didn't have water in a very key stage for fruit development. So not everyone in Washington has that excessive water availability. And so some of them, and we are facing, maybe we're going to have shorter availability during the summer. So we will see how that goes as we move into the season.
Hey, Bernardita, I want to so I see the question from Kirti, and to understand, so David or Kevin, could you explain what is going on in the Lake Ontario Fruit region in the way how we pay for the water, that we cannot pump water from Lake Ontario? Could you elaborate, explain a little more that, please?
Sure. Lake Ontario is part of an international agreement with Canada and US. That's international waters. So it's federal permits to pump directly out of Lake Ontario for us. So all municipalities along Lake Ontario are pumping out of rivers or streams or reservoirs they've come up with just because of regulations with EPA. The other challenge is, like, we're in Niagara County, so we have Niagara River next to us. We're below the river and where they draw in. So pumping to us is very cheap since we're almost 200 feet below the inlet for the whole county system, where other counties have a lot of height elevation issues, or the pumping a lot of distance to get to the towns they want to pump to, such as next county over is Orleans County. They're buying water from Niagara County, so you have one municipality upping the charge to another municipality, then selling it to the township, then selling it to the customer. So it goes through three hands of ownership before you actually get your water at some of the neighbors' towns. Some of the farmers in Hudson Valley and Champlain Valley, even Wayne County, they have townships that don't have systems that go into their farm regions at all. So they have to then pay for wells, permits for that, or make their own reservoirs, like Brian mentioned. But not many farms are lucky as Brian having naturally fed ponds like that. So every municipality is so much different that's why there's a price range between, I think we're the cheapest, $175, but the highest I've seen for New York State is $9 1,000 for ag water, if you can get it. The other thing is also age of system. That system, when they put it in, it was cheaper. To add water capacity piping nowadays, everyone knows the cost of production has gone up a lot. So to add miles of water pipes to get to certain areas, it's not as cheap as it used to be.
Thank you.
Just to add, I know that we have we are in time for finishing, but I just wanted to follow up with Molly and Aaron in terms of, you both mentioned strategies to deal with these water availability changes, so cover crops or changing to drip irrigation or not. How, just in very general terms, maybe how these have impacted your production decisions and strategies? Have you had to add more cost to the operation so you can deal with this, or not really? You haven't really seen that. Molly, you can go ahead.
Yeah, I think the cost of production certainly does go up in our case, Bernardita. As Aaron said, since 2019, we've been exclusively picking cherries at night. It's not a quick process. It's a slow process. It's required additional planning and infrastructure, as well as recruiting additional people. I didn't mention, we've had severe forest fires in our area as well, which even just the conditions around smoke and difficult, heat conditions have made it difficult on people for working, and have required additional personal protective equipment and trainings and safety plans that, all seem to add to the cost. We don't think of it as a tangible good going into fruit production, but it very much becomes a cost of doing business. And, as mentioned, in doubling up on irrigation systems or changing systems, or, we're now trying to renovate old systems that we don't find to be as effective, or old infrastructure, as was said, is quite expensive to replace in many cases. So I think that does add to the costs. We were very fortunate through some of the best management practices funding to be able to buy a no-till seed drill, which has helped us immensely in successfully planting cover crops in these dry conditions, being able to take advantage of moisture early spring in the soil and getting those crops seeded using a diversity of species. We're not sure if we have it right. There's other factors, of course, including little cherry issues, in Western X, but we just want, we're trying all sorts of different things, but even that grower research and innovation is expensive. So we've been very happy that there's been some government funds and support for that type of work too.
Thank you, Molly. And Aaron, we're going to finish with you.
Well, Bernardita, can you tell me the question again, or just...
Yeah, just thinking about it. So you have shared some changes that you have to do in your orchard, like doubling the irrigation lines, or maybe removing or not the cover crops, having netting, or maybe sunburn protection. How these events or climatic events have changed your operation in terms of the cost? Have they increased? Do you see a clear increase in cost related to these events?
It's I mean, there's a cost associated with it. I guess the things that we've been really working on, like I said, it's a big investment to put shade netting over things. It's really pricey. Like Molly said too, we've focused a lot over the last, I don't know. I mean, it's always changing. We're always updating things. And so just the irrigation systems, we like drip. We've used it forever, but it doesn't overhead cool and it doesn't frost protect. So, but even on those systems, we're updating. Back in the day, it used to be overhead, or it used to be impact sprinklers or big R2000s. They'll put out 2-3 gallons a minute per sprinkler, and now we're down to micro sprinklers in most everywhere. And so, it's just trying to be wise, but being wise and being, sustainable and trying to make sure that we're resilient when we need to be, and putting out less water and using it better. We've put in VFD pumps everywhere. We have 12 different reservoirs, ponds that we draw from that will fill up. We like to pulse irrigate, for example, so you can't really do that without getting increasing your automation on things. So we've invested a lot in automation so that we can do an hour on and an hour off. And same with overhead cooling. I don't like to run solid sets for when it's hot. I like to do 20 minutes on, 20 minutes off. And none of that's possible with people driving around to 200 different blocks on a four-wheeler, changing it every 20 minutes. So we've made the investments to the systems. And then, we're trying to do what we can, but it's a battle, and we just can't seem to get away from overhead cooling. It's just such a necessity here. No matter what we do, we've grown without it, but the fruit quality is really pretty poor. So, but I think that's our big cost increases, and just changing the way we do a lot of things. But irrigation wise, we've just updating all the systems and automating them has been a big cost.
Thank you, Aaron. And thank you, everybody, for staying late in the Eastern. Of course, we know that you are much later than us. And a lot of this conversation, as usual, we have still a lot of questions. I have a lot of questions for you. And so you are clearly invited to join us in the next session, which we're going to be talking of what just Aaron just mentioned about fruit quality. So how these events, including frost or heat, and how we irrigate have impacted fruit quality, fruit yield, and how we have to manage that, choosing different rootstocks or training systems. So we're going to deep dive on those for the next session, which is next Thursday at the same time in the same channel. That's like an old style invitation. So Mario, do you want to add anything? And while Mario can say goodbye to all, I will add a link for a survey so you can not only give us some feedback, but also ask some questions and give us some information of what you would like to hear in the next session.